Hello everyone. In this lecture, we are going to learn about one very interesting multi-threading concept that is known as semaphore. So here you will know about semaphore. Now we will know semaphore. This is one of the most important tools that you are going to use in thread synchronization. So let me remind you a little bit about threads. So threads, why they are so important? When you do with your computer, you want it to do multiple jobs at the same time. So here is an example. If you have a printer, here a printer resource, and it might set within many people on the line, and all of you are connected to this printer, and now anyone on the line can find the printer and they are using the printer, but the printer one time can only print one thing given by one user, one of the users on the line, but multiple people can at the same time give it to work. So how does it work? This is a resource. It can only do one work at a time. Otherwise, it do with some users, and it maybe have some wrong printing. So what do you do? Here we have a queue. Yes, we have a queue here. This is a queue, and if two of them parallelly find that work, I will user 1 and user 2, user 1 ET1, user 2 ET2. Sorry, because I pen so bad. And it is all of them, both of them are in the queue, and they will print one by one. So this printer can only do one project at a time. So how is done by the computer? So in the computer, you use a concept to know as semaphore. So what it does, there is some resource, and it can be used by multiple users. So it decides how many people can use it at the time. We will see a part of the code that we have now a critical section. Oh my god. Critical section. So critical section is very important concept in operating system. So this is a piece of code. It's a piece of code, and in this block we have a variable or data structure. I will write it is dt, which can only run by one thread at a time. So how should we code be written so that one thread data type can run them and execute the critical section of the code? And this concept is known as mutual exclusion. That means the critical section of the code can only run by one of the thread data type. So this critical section, they might be the code to execute this printing. So this code can be run by only one thread or one user at a time. Okay. Now here is my code. First, I have a class named Semaphore. So how we did it with Semaphore? Now this is the code. We have a class named Semaphore and it has a value. Basically, this value is how many users or how many threads can parallelly access the resource. So here, Semaphore init, and this constructor here value is how many users can access the resource at the same time. I comment this. And then what you do? We have two methods here. The first one is the method down. This is a p function of the Semaphore. P function Semaphore. It says I'm acquiring the resource. And it can acquire only if value is greater than 0. But if the value is equal to 0, it means no resource is available. And what you need to do? So this thread needs to wait. Now I will ask, what is this wait method? This wait method is when you try to acquire new resource and you haven't got it, it will be a blocking code. So this is wait if no resource is available. Now what thread? That thread is just waiting. Okay, then what happened now? When some other thread, here is the waiting and value becomes 1. So this thread is now notify the person that the thread is waiting, and this wait ends because value is now 1, not 0 anymore. The blocking ends, and we again go to the while loop and see that value now becomes 1 or 2 or 3, blah blah, so on, whatever greater than 0. Now this block will end and it will decrement the value minus. So what is this happening? I am one thread, have one thread T1. Sorry, I will print it in here. I have T1 and T2. And maybe just 2 is another thread, and let's say only one of them can use. Value here is 1. So when I come to down method here, what happens with the value? Because T2 is already using it, so value is 0. So now value T is using, so go to T1. Value is 0 now, so T1 will be in wait function, and I'm waiting here, so T1 wait. So now go to second method up now. It means that one thread had already required the resource. He is now releasing this resource. This is V function of Semaphore. He is releasing that resource. So what he does, he will make the value available greater by 1, and this value is we decrement it and notify all threads that are waiting for other value to become greater than 0. So it is that method, or basically releasing resource method. Okay. So now what happens? Now we go here and we can understand this code. We are waiting when someone releasing the resource, and blocking code ends. Blocking code ends, and go again to the while loop. Value is 0 is false now. If we come out and value is not 0 anymore, I come here and decrement the value. It means I am acquiring the resource, and this way semaphore works. Okay, I have an example for you now. So let's say value here is 1. Value is 1. It means that one resource is there. Now I have two users, user 1 and user 2, and now user 2 acquiring the resource. So I go to down. Value is not 0 now. So it come here and it come here and it will make the value decrement, the value minus, and value now is become 0. So user 2 come and user 1 come, and it finds that user 1 finds that the value is now 0. Value is 0 for user 1. So he will be in the wait. So user 2 using the resource, he will go to up function and decrement value plus, and now value again become 1, because at the past value is 0. So here the value plus and it's become 1. So user 2 release the resource, and now is the one who was waiting. So value now user 1 who was waiting. So value now is 1, and user 2 released the resource, and I was notified. So remove wait and go again to the loop value, the while loop, and value now is 0, but now value is 1. Sorry, value is 1. So I come out here and value decrement. Value minus means I acquire the resource, and now I come out again, value to decrement. So user 1 acquires the resource, it can be used. For example, if the value is 2 or 3 or 5 or so on, whatever it is, when someone acquires the resource, value y, for example, value now is 5. When someone acquires the resource, value will minus and become 4. It's still greater than 0. So another user allowed to come. So value now becomes 3, become 2, become 1, so on. It is this way it works. So we want to run this code and we see what is happening. We will look at another code named multi-threading, where we have a main function. Sorry, we have main method. Now n is the number of threads in the critical section, and it equals to 3. It means that we allow 3 threads to be in that critical section. So what we do, we have a mutex semaphore object and allow 3 users or 3 threads to be in this critical section. And now we run with mutex threads. Okay, what is mutex thread? I will show you. we have a class multi-thread exchange thread. So this class is thread class. And here we have a mutex semaphore, semaphore mutex, and mutex thread now has a name. Here is a constructor, and it starts. And when it starts, it will return to the method run here. Method run here. It acquires in the method. It acquires the log and bring enter critical section and the thread name. But here it sleeps for some time for random and get up and leave critical section and release the lock, and only maximum 3 twists can only go into that clock because that will happen. Thread 1 will come, so mutex drop down, mutex drop down and acquire that lock only if that the value is greater than 0, greater or than equal to 0. So it can acquire by maximum 3 twists at a time. Run this code. Let's see somehow output. Okay. I will show you here. Run the file and see what happened. Okay, I will stop it and see some result at the beginning. So we see that in here we have 10 threads. And we start 10 threads at the all of them can enter the method, run method. That happen with first 3 threads. Here I get start, and so first value is 3. So what happened now? First thread 1 come out, so it start acquire the lock. So value now is minus and become 2. Thread 2 becomes, and the value minus and become 1. The thread 2 come acquire the lock, value still greater than 0, acquire the resource, declaring the value, and now value becomes now is 0. So now another user or another thread come here because the value is now 0. So whatever threads are now coming, they will be now waiting or as a lock. And now you see that the first thread to leave the last thread that are coming in the critical section. So this due to random sleep function. Random sleep function here. The random sleep function. So thread. Okay. So sorry. So thread to come here and go out there, and when go out there, so you're releasing the lock. So what do you do? So let's see another thread come out and they asking to release resource. So what happened? So thread okay, yes, thread 2 will leave, and so the value plus and it will notify other thread that were asking to the resource. So you see again here, thread 2 enter again and leave, enter and leave. maybe in here the randomly is not good, but whatever. So thread to leave, so the value plus and notify other thread that will asking the resource. So you see here the thread 3 enter and it leaves the critical section and leave 1 leave 4 enter 2 leave or whatever, so on. So I go to the main function, go main thread. So here is the loop that I was running 10 threads were there and they asked to the same critical section. Now here is the first, in fact, that they release the resource and they are trying again to access this resource. The moment here is they are releasing the resource and when again in the while loop, if you see they again jump to acquire the resource. Okay, and maybe here I have thread 1, thread 2, thread 7, thread 5, blah blah. It randomly to enter that critical section, not first in, first out. That might be happening. That depends on your operating system. Okay, that is how Semaphore works. Okay, now I have a application and show you. Okay, in this lecture we will look at the one application of Semaphore. So first we will look at the code which have some faults in it, and then we will know how to can correct it using semaphores. First code here, let's look at it. First code is about generating odd number. You can generate odd numbers. In fact, this is a class which is generate odd number. So here we have a value n is 1, and now any thread can come and request this class to give it new odd number. So it's very simple to give odd number. What it does, it starts with a value n equals to 1, and in the list method here, what it does is very simple. It does 2 times the increment n, and n first is 1, and we decrement the n by 1 2 times. But between that, here, what did it do? It is just sleeping for some times. It will be very simple to generate new odd number, but our problem here between the sleep for some time, and he claims that he will run fine, and it will be the first 1, next 3, next 5, next 7, and so on, and he say he's done. Now see the code. We have class or to extend thread here, and it will be the thread class, and it use alt e here, below the object here. I have the constructor, and in the run method, what it does, it will print 10 odd numbers. So we have a main function. And we create a odd object that we call to an odd object e here, and we go to ought to thread here. It is T1 and T2. Both of them are using step E. Are using E. And now I will start, and they hope they will bring together all numbers. So see the result. Here, oh my God, why? We want to generate odd number. But in fact, in the first result, it's not odd number. Next is 5. Okay, this what is correct. But next is 8. Next is 9 and 12 and 13 and 16, blah blah blah. Something wrong here. Sometimes I'm correct, but sometimes not. So this code is wrong. So we use Semaphore to correct. Now, why is green gone? Come back to the odd class in here. Let's see that. Now we have a T1 and T2 is 2 threads, and N now is 1. It's the first next. The T1 we increment the N, and N now we become. Okay, I will draw it here, and you will know what happened. I have a T1 and T2 here. T1 and T2. The first N now is 1. But when T1 acquires the resource, it increments plus N, and it becomes 2. But at the moment, or maybe in the very short time, T2 accepts the resource, and it increments N. And now, because before N now it become, N become 2, and now it becomes 3. Okay. Before a random slipping, the N we in T1 we increment one more time, and it will become 4. So it brings, and we see that the first result here is 4, and it's the same. The T2 increment the N, and now it becomes 5. Okay, and next, in the next, the N we increment in the 2 times, but because now here we have 2 threads, I should acquiring the resource, and so maybe in the why we sleeping, because we both of the threads are access the resource, and it's wrong. So now we will see what can correct it. Okay, now here I have a R3 class, and I will correct it. The first here I have a class is the odd mutex. What is the odd mutex here? In here I have a N value. I have a N value is the 1, and here is I will accept 1 user or 1 thread can access this other time. Here is the init and the constructor to create it. On the below I have a next method. In the next method here I will here the mutex down and mutex up. mixed down, you mix up in between the operation we to generate the odd number. In the mutate round, here is accept just one method or one thread or one user can access the result at a time. So here, because here is atomic, so it is simple for me to correct it, because in there no other thread can access while one thread accessing. So in the class auth3action thread, a class thread, here I have auth mutate here, and I will implement it in constructor. In the run here, I will print 10 auth number, and in the main you will see I have auth mutate E1 and new mutate. Now it's fine, and here, okay. So see what happened. Oh, sorry. It's not fine. It's just one. Okay. Oh my God. Why is false? I don't know how it falls. Sorry, I will check it later.